Now, algebra. There were more problems involving algebra. 13 to a 15, a lot of algebra. 16 to 19, a lot of algebra. And then there's a 16 to 19. And I thought those were pretty interesting. They combine both algebra and functions. Look at some of the things. For 16 to 19, substituting numbers. You know, x is 3 and y is, I don't know, 10. What's x plus y or something like that. Solving one-step equations, just one step. Combining like terms. Yeah, you all can do that. And that was, you know, if you've got a range of 16 to 19. Okay, find number 12 in your booklets for me. Now translate. What is it saying? What quantity? Read it for me.
What quantity must be added to 4x squared plus x minus 5 to obtain x squared plus 5x plus 1?
Right. Now translate. That's part English, part math. You're going to translate it into all math. What quantity? Is that something we know or don't know? We don't know it. What do we call something we don't know? What are we going to use? A variable. Why the word vary? Wait a minute. What's the verb vary mean? Different. To change. Difference. Right. That's why it's called a variable, because in one problem x can be a 2, and in another problem x can be a 3. Right. Or 157, or whatever it is. Now translate word for word. What quantity? Okay. Use a question mark, use an X, use a P, use a Q. By the way, I don't believe in always using X's and Y's, and you'll see later. You know, if they're talking about boys and girls, why don't you use B's and G's instead of X's and Y's? Use what's relevant in the problem. Okay, so what quantity must be added to 4x squared plus x? Now everybody do it on your paper. They give you a whole half a sheet, half a page, to get x squared plus 5x plus 1. What are you going to do to solve for Q? What operation? I want the Q to stand alone. Right. Subtraction is will this go sideways? I guess in my next problem I'm trying to see if it goes sideways. Right, it's subtraction of like terms, right? So you're going to subtract 4x squared from both sides, and you'll get what? X squared minus 4x squared is? Come on, what? Beautiful, negative 3x squared. Okay, and then I'm subtracting I got a positive x, and I'm subtracting x from, beautiful, 4x. Now keep one eye on the answers. You may not have to do any more than that. Take a look. Is that enough? Yeah. Is it? Yeah. Always keep one eye on the answers, because you started with q plus 4x squared plus x minus 5, and then you want to get x squared. And I love that you said subtraction. If you translate, you'll see that. How do you get the isolate? If you have the flu, Somebody's going to isolate you, make you set apart from everybody else. That's all you're trying to do. You're trying to solve for Q, which stands for quantity. So you've got to get rid of the negative 4x squared. And again, please think of an equation as a teeter-totter. That's all it is. And if you add something to one side or subtract something and you want to keep the weight of the teeter-totter the same, you've got to do the same thing to both sides. And that's what you've got. So you've erased him here. And now you've got a positive x squared and a minus 4x squared. So that's got to be, you already told me, 3x squared. Now I got to erase him. Whatever I do to one side, got to do the other. 5x minus x is positive 4x. Yeah. And keep one eye on the answers, because you keep one eye on the answers because you just don't have to do that much work. Yeah. 3-step, 2-step, or 3-step arithmetic problems. So let's see what the problem is. There it is, number 15. Volunteer to read it. Read it for us.
414.
Right.
Price of storage charges for a small refrigerator consists of the refrigerator's original cost to the store plus a profit of 15%. What was the refrigerator's original cost to the store?
Okay, so on your papers, please underline what they want. Refrigerator's original cost. So that's your unknown. What variable do you want to use for original cost?
P.
Who? P for price, right? Okay. So now translate. Anybody know what part of speech consists is? Where did I hear that? Verb. Excellent. Use it in a sentence. In another sentence. Yeah, consists. Your verb, gang, is usually your equal sign. Pure and simple. Seriously, an is an equal sign. An is a verb. Usually when I find the verb, that's my equal sign. So everything starts with the parts of speech. Okay, so now, English language for the most part, and you're going to turn it into math language, and there's your equal sign. What's our math language prior to the verb? How much? 414. And see how you can translate it. 414 consists of the original, and what variable did you want to use? P plus, well, that was easy because PLUS in English turns into a plus sign symbol in math language. And now a profit, how do we write 15% either as a fraction or as a decimal? 0.15. Now, percents do not hang in mid-air. They're always a part of something. And so it's 15% of the price. It's not 15% of the $414. It's 15% of the price. Yeah, that's all they're doing. And now translate it. $414. You were the one who read it. Let's translate it back into English. Start. 414 is, or consists of, the plus of price, right? In other words, math language is fewer symbols, and so it's just so nice. Look how many English symbols they had to use to spell out the same problem.
So why we put the P twice?
I thought it was supposed to be two different variables.
Well, okay. Oh, that's an excellent question. Oh, I like that. You could have done 414 equals the price plus, oh dear, if we're going to use P for price, we can't use P for profit. Anybody got another letter? Q. Okay, is that our profit? So yes, to answer your question, in the beginning, you can have two variables. However, how many equations do you need? If you've got two variables, how many equations do you need to come up with an answer? 2. If you have 3 variables, how many equations do you need? 3. You only got, right. So, okay. So let's pretend you started with this. That was a very nice question. Okay. You can't solve this because I don't have a second equation, but we do know that the profit is 15%. The profit is, notice my translation, the profit is 15% of the price. I have 2 equations, I have 2 unknowns, you're absolutely right. How do we smush 2 equations together here? With substitution. Knock out the Q and put in the, that was excellent. Who asked that? Yeah, that was, I will tell you all the lollipop story. Would you pass it back? Some of you, I think, were here earlier and I already mentioned. Right, okay, now here's the key. And this is probably why it makes it a, was it a 20 to a, yeah, okay. What was up there? Solve a routine, notice that adjective, meaning it's a pretty common problem. You do a routine over and over again if you're in drill team or something, or in football or whatever. You're doing it over and over again. But it's a 2-step or a 3-step arithmetic problem. Rates and proportions, tax, percents, that's the kind of thing that you need if you want to use your ACT as your part of your pathway to getting a high school diploma, you all who are juniors. That's the kind of problem that you need, and that's why I chose that kind of problem from that ACT, and that is a real retired ACT. Okay, the tough part of the problem, what's P plus 0.15P? What's the coefficient? What's the number here? And we don't bother writing it because we'd be writing it. 1, right. So if it's a 1P plus 0.15P, absolutely, nice. It's 1.15P. And now what are you going to do to isolate the P? Divide both sides by, again, it's a teeter-totter, whatever you do to one side, you're trying to get this guy to stand alone. So if you introduce this here, you've got to introduce it there and divide. And you could pull out your calculators. I got to take a look at the answers. Do I really think you need to? What problem number was that? 15? Are there any other answers that begin with a 3? Oh, there are 2 answers that begin with a 3. Sorry, because what I was thinking, right. I was thinking if you divide $1.15 into $4.15, about how many times will it go? 3. So I was thinking, okay, if there's only one answer that began with a 3, but you could pull out your calculators. What did it come out to be?
360.
Yeah. But that one, yeah, it's a word problem. Percents are important. And again, just write it down. Percents do not just hang in midair. It's always a part of something else. A part of something else. And by the way, this I did in my ACT course that started last weekend. Let's get it straight. A percent sign is a 1 and 2 zeros. If you didn't know that, that's what it is. It's a 1 and 2 zeros. And Monday, Wednesday, and Friday, you write it like that. Tuesday, Thursday, and Saturday, you write it like that. They are the same. I don't know what you do on Sunday. On Sunday, I guess you do it as a decimal if you've got... Right, it's the same. This is a 1 and 2 zeros that you've written to the right. You can't graduate from high school and not understand that. I want you to be intelligent consumers.
So we write percent differently based on the day?
The what?
We write percent different based on the day?
Right, exactly.
So if it's Tuesday,
Yeah, sometimes, right, if it's Tuesday, I'll write it one way. Yeah, that's what it is. And it means that again, because I'm not a mathematician, I pretend there's an imaginary world where the whole is always 100. 100 kids, 100 red shoes, 100 pencils, 100 Sprite bottles, whatever it is, that's your whole is always 100. And then you're just saying, okay, every 6 out of 100 or whatever it might be. And so that's my imaginary world where the whole is always 100. And so if you have 6% and say give me the number of kids in one of your classes. Okay. So all you're doing, gang, you have this imaginary, so 6% of them play football. Okay. So in the imaginary world, 6 kids, guys, I guess, out of every 100 play football. In your real world, so I set up a real world and an imaginary world, and that's all you're doing with percent. And why do we use 100? Because our money system is based on dollars and decimals, and we can visualize what 6 pennies is out of 100 pennies or whatever it would be. So that's all you're doing with a percent. You've got this imaginary world where your whole is always 100. Here in your real world, your class has 30. And you're trying to see how many in the real world would be equal to the 6 out of 100 that you could picture. Now I'm going to teach you something. Okay, if you have a proportion, what do you do next? Cross multiply, beautiful. Now, if I teach you this, don't screw it up. Okay. You can cancel with proportions to make your multiplication shorter and easier if you pretend that they're arrowheads on the ends of the equal sign. Don't cancel, don't simplify going this way. You gotta do this. Okay, what can I do with the 30 and 100? What's a factor of both of those? Gorgeous, 10. How many 10s in 30? 10s in 100? Now cross multiply. 10x equals 18. In other words, I'm cross multiplying. My next step would be and I could even reduce here. Let's even reduce here. Come on, 6 and 10. What's the common factor? What goes into both? 2. How many 2s in 6? 3. How How many 2's in 10? Now cross multiply. 5x equals 9. So x would be almost 2, 1 plus, whatever it would be. So about 1 student out of the 30, well, it'd be a little more, but about 2 students out of the 30 maybe play whatever it is, football. But yeah, just that's all a percent is a imaginary world that we are able to picture because our money system is based on hundreds and ones and tens and that kind of thing. Okay, functions. What do I do with that? Say it again. You got to plug it in. Got to plug it. It is what part of speech? Pronoun. What is it standing for in the problem? What number? What number in this problem? What are we plugging in? The 3. You're plugging in the 3, right. And whom, I got to think of my who and whom's because that and I, if we do English later, there's a difference between who and whom. Whom am I going to plug it in first? The G, right. Now, here's the deal. Again, because I deal with 3 languages. When a picture is worth 1,000 words, this is saying to me, and keep these functions, keep them easy. They are easy. Okay, so when a picture is worth 1,000 words, it's saying to me, what's the English translation for that little 2? Square. Square whom. Now don't use the word X. Where is he? In the yeah. All it's saying is square the guy in parentheses. Picture's worth 1,000 words. That's what they want you to do. Square the guy in parentheses. Okay. And the G is here. What do they want me to do to the guy in parentheses? Square it. And what's 3 squared? And be careful, they love that because kids will put 6. What's 3 squared? 9. Right. Okay. So now I have a big 9 in my parentheses. All right. How does this one translate into English? What are you doing to the guy in parentheses? What's the English translation for multiplying by 2? Yes. Who said that? Say it again. Double it. Yeah. Very nice. Right. That's how. See, again. It's another language. It's just a language. So a picture is worth 1,000 words. Because a lot of times they'll show you this rule, but then all of a sudden the problem will have M's and N's in it or something like that. So what happened to my X's? Well, if you translate it as just follow a rule about the guy in parentheses, they want you to double. Okay, so what did we have here? 9, and they want you to double that now, and you get 18. Yeah. Just don't talk about X's and Y's all the time, because if they change the variable, because that's what it means, I want you to be able to do it. And the hardest function problem, if you just translate it, look at it, and decide what they're doing with it, what operations, I mean, it's going to add, subtract, multiply, divide. Yeah, that's all I did. They said square it, I squared it. But be careful about 3 squared. It's so easy to... Okay, Now, if you want a 24 to a 20, look at all those algebra. This test, just like the PSAT and the SAT, and I have to put in a plug for the SAT, it's based on algebra as well. And all of those types of problems, and you've got that on, I don't know what page in your book, but all of those are types of problems. Difference of squares, oh yeah, all right, we've got to. How does that factor? Notice difference, that's my English, that means subtraction. Square, square, that's the English. Difference of square, how's it factor? Gotta know that one. Come on. A. These should have been drilled and drilled and drilled. A, come on. Yes, yes, come on. And yes. Oh, write it down. Get those memorized. And why does it come out to be that? Come on, do the FOIL. What's A times A? A squared. Outer. Outer. Negative AB. Inner. Positive AB or BA. And what happens to a negative AB and a positive AB? They cancel out. And then last term times last term is B squared. Gotta know those three patterns. And that's what it says here. Where'd it go? Right, working with squares. They should have drilled you and drilled you and drilled you on those. Okay, that's one, A squared minus B squared. How about, there's only three of them, but they need to be permanently ingrained in your minds. A squared plus 2AB plus B squared, how does that factor? Well, A squared has to be A and A, whoops, and B squared has to be B and B, and what's your sign in the middle? Plus, sure. This one is A plus B, the quantity squared. And then the other one, so this is A plus B, the quantity squared, and then your other one has to be A minus B, the quantity squared. Please commit those to memory, but especially difference of squares. I mean, they're just they're all over the place. Work with squares and square roots of numbers, difference of squares, perfect squares. And that's for a 24 to a 27. You all can do it. But it takes practice. Find number 25. How does that factor? Let it talk to you in English. I see 4x squared, so that's a square. And I see 9, and that's a square. And I see a minus sign, so that's a, in English, difference. So that's a difference of two squares. Come on, everybody factor it. There's your first, that's this pattern. Difference of squares. That's your, right. So somebody raise your hand. Think what it was that they collected, they had 4x squared. And so the first thing you did, you looked at it and you translated and said, oh, I've got a perfect square difference. So I guess it's going to factor like this. Okay, to get 4x squared, this had to have been a and a 2x and a 2x. We know from perfect square that I've got 1. Beautiful. And so, and they have it equal to 0. Okay. So what do you do next? Yes, you do no. If this times this is 0, if this times this is 0, then that means one of these guys has to be 0, because 0 times anything is 0, right? So if you say, okay, this one is really 0, solve it. X, add 3, beautiful, add 3 to both sides, and then divide by 2. Keep one eye on the answers. Do I have to do this one? I can't remember. I got X to be... Oh, yeah, you'll get negative. Yeah, it's got to be B. But actually, you could stop, even though for X we got the positive 3/2, you have to stop there because you don't have to find the other. Always keep one eye on the answers.